Hello again. This brief video will look at our second example for linear programming in Excel. Now this is a more complicated spreadsheet, but it follows the same pattern as our first example, which is much more simple. What I have at the top of this spreadsheet is the data as given in the problem. So remember, we are making subcompacts, compacts, luxury, trucks, vans, okay, different types of vehicles. Okay, so here is how much profit we make off of each one, what the market requirement is for each one. The efficiency is the miles per gallon that that type of vehicle can get. The target efficiency is we want a fleet efficiency of, on average, of 27 miles per gallon. Okay, here's our decision variables, again coded in yellow. So I'm right now assuming that we're making one of each type of vehicle. So we again have our different types of vehicles, and I'm assuming we're making one of each. This is our profit margin off of each type of vehicle, and this is again a live spreadsheet. So if I change how many luxuries I'm making, it updates the profit. Okay? Now, you notice here I'm using that SumProduct command. I have my constraints set up in a way so that I can also use the SumProduct. So for instance, the vendor constraint is how much the vendors can handle. So the total number of cars that we can handle is 1,200,000 vehicles. So if I take 1 times the number of subcompacts plus 1 times the number of compacts plus on and on and on, that sums right now to 15 based on what I have. So if you look here, that's a SumProduct command. As you scroll down and look at the different rows, every single row is going to be set up as a SumProduct command. Okay, that's one of the advantages of doing the spreadsheet this way. If you have questions about that, ask me. This is the way the book does them too, and I really like this technique. So here we have all our constraints through SumProducts on our manufacturing plants, on our overall efficiency of the cars, on the mix of vehicles, and then the market demands in each sector. We have here what those constraints are, and then whether it's less than or greater than. So let's activate Solver. And again, I have this pre-populated so that I can keep the videos shorter, but you would need to fill these in. So our objective is I-12, that's again the profit. We want to maximize profit by changing C10 through H10, that's our decision variables, the yellow. And then we have constraints. Now this time I have the constraints entered as 3 sets because if you look, the first 4 constraints must be less than or equal to, the next 2 are greater than or equal to, and then the final 6 are less than or equal to again. So in order to make sure I'm applying the right relationship, I use those ranges. So for the first 4, I said I14 through I17, that's the first 4 red values, must be less than or equal to K14 through K17. That's the first 4 blue values. So on an individual basis, the first one must be less than the first one, second one must be less than the second one, red versus blue. Okay, now we're going to click the box again to tell it that we can't have negative decision variables. That means we can't make negative cars, which is obvious to us but not obvious to Excel. And then finally that we have a linear problem, so we'll use the simplex algorithm because it's more accurate for linear problems. Okay, and we should be ready to solve. So let's see what happens. Sure enough, it found a solution. All constraints and optimality values are satisfied, so let's keep it. And you'll see it tells us to make subcompacts, compacts, intermediates, luxuries, trucks. We do not make any vans, however. The profit margin on vans is really, really low, and they don't help us in other ways, so we're not going to make them. Now let's look at a few other things here. You'll notice that trucks are very, very profitable. We're making as many trucks as we possibly can to the limitation of our manufacturing plant. We're making a bunch of subcompacts and compacts. We're totally utilizing the capabilities of our manufacturing plant there. in order to help out our overall fuel efficiency ratio. But you'll notice we're underutilizing plant 2. Okay, you can see here in this row, plant 2, we're only building 300,000 cars there when it has the capability of building 400,000. The reason is that we don't need to make more. We're satisfying other conditions. We're reaching the most that we need. We need to make sure our overall fuel efficiency ratio is okay, things like that. So we're satisfying other aspects first. This means we're reaching other binding constraints before we reach this constraint. So what this again tells me is that we're really learning that that plant is being underutilized and we need to think about retooling that plant to do something different. Okay, so going on down, you can make other observations. For instance, the market could allow more subcompacts, but we don't want to build any more than we have to because the profit margin is not as large. We're going to make as many as we can of the ones that have a larger profit margin. So you can see that we're underutilizing other areas as well. But the big learning is that we're underutilizing plant 2. One last thing I want to point out is you'll notice here we're making fractional cars. So here we have a 2/3 of a car and here we have a 1/3 of a car. Later on we will deal with that. For right now, if that bothers you, you can highlight those and then come up here and get rid of the decimal places so it'll round. Later on we will apply integer constraints to force it to find whole number answers, but right now we're not going to do that until we get to that unit.